this gives a more meaningful options. So if you look at the data here, the data is read into two different formats. One is the horizontal flattening and the vertical flattening. Again, it does not have much big definitions. So if you flatten the data horizontally in a way that the parent and the child is available in node, and the node parent is available, and on level A, what is level 0, what is present, level 1, what is present, and level 2, what is present. That is the horizontal flattening. And vertical flattening is nothing but it does a vertical flattening where it gives you the relationship between each and other node. So it gives you a relationship between the parent node, the child node, and the depth between them, the root flag, what is the root flag and what is the leaf flag. So this kind of gives you a clear understanding on the data, like what we are trying to get and is the data good or not. So because rather than seeing the data in this format, alright, so in this tabular format, it is always to look at this data, it is always good to look at this data in a horizontal flattening or a vertical flattening. So how do we read this one? So if B is the last node, so if B is the node, the level level 0 means the top node of this one is A, and on the level 1 you have B, and on the level 2 you have D. So F is the node, then if the level 0, the parent, the grandparent of F is A, and the parent of F is C, and at level 2 we have F. And if you just look at A is the node, and at level 0 A is present, and we have to just always look at the parents. So there are no parents and no base levels of A. So similarly, if you look at B is present in the second level of this one. So this is a horizontal flattening. So flattening happens always on a horizontal nodes. And this is the vertical flattening. So this one gives you, if you take it this one, the highlighted one, A and F, A is the ancestor, F is the descendant, means the child of A, and the depth between these two is 2, because A to C is one level and C to F is the another level, and the root flag is A and the leaf flag is F. So this is how the data owners will read this. So our responsibility to flatten that and give the structure to the data owners so they can read this and understand it more clearly, because sometimes you cannot try to read that data just looking at the table, or you cannot understand just looking at the structure. So you need to flatten the hierarchical structures, and BODS provides you the jobs or the transformations using which you can do a flattening. So now I'm creating a job, a hierarchical flattening, a data flow for hierarchical flattening. Okay, so just give me a second, let me see what source did I use for this. Yeah, I have created some source table. Okay, this is the source table, the flat file which I have created. Some minimal simple examples which will give us a clear picture of like what you are trying to do. So here A is a manager. So this is parent and this is parent description, this is child and this is child description. So we have a manager and a senior lead is reporting to the manager. So we have a manager and a lead is also reporting to the manager. We have the senior lead and the developer is reporting to the senior lead. We have a senior lead and junior developer is reporting to the senior lead, and we have a lead for whom the trainee is reporting. So this is a normal simple day-to-day activities or day-to-day example. So this is a simple parent-child table, and I will be using this parent-child table to demonstrate the hierarchical flattening and vertical flattening. So now first let me add that table, that Excel sheet into my BODS designer. So don't forget this, when we have a data in the form of a flat file, so we need to add that flat file into the BODS system first, then only we can utilize that. So source flat files is the file folder, okay, and select the file. So click on parent child.xls, that is the file in which we are trying to do, and worksheet is sheet 1. Then use the first row columns, first row values as the column values. Import schema, yeah. So I have the parent, child, parent description and child description. 4 columns are present. Okay, now I make it as my source, and if you look at the data, I have the data here. Can we have a question? Named range is something like, you know, from where the data is present. So you give here from A1 to ABCD 10. So what it does is, if you open the Excel sheet, this is A1 from here to D10. So first row, first column to fourth column, 10th row. It will take the data from that range. So if you have data more than that, it will not take that data range. So generally we go for a worksheet because BODS is smart enough to just take whatever is required. Okay, so that's a good question. Right, so now I'm making it as a source, and I will be using this one, hierarchy flattening transformation here, and connecting it to my source table. So if you open the hierarchical flattening transformation, this is how it looks. You have a schema in, you have an empty schema out, flattening, types of flattening and different options related to the flattening here. If it is vertical, we have separate GUI, and if it is horizontal, we have a separate GUI. Then you have parent column, child column, parent description and child description. And since this is again a performance optimized thing, so you can check this box to run this as a separate job. So first let us do the vertical flattening here. So if I select vertical flattening, so use maximum length paths, so it is automatically checking that. So parent, you can drag and drop it here, or you can select the drop down list and select the parent here. And parent description, because parent attributes, what are, it is like material number is the parent column, and material type, material description, material category, and all these things will be your attribute list for the particular material. So similarly, drag and drop the child here and the child description, and all you need to do is like click on validate. Once you drag and drop this, the schema out is not populated, just validate this one. Click on validate, and the schema out is automatically calculated. So just go back, connect it to the table. I just named it as hierarchical flattening because same table we'll be using for both vertical and horizontal flattening. Okay, so save this. Now validate to see if there are any errors. No errors found. So now remember, we are doing a vertical flattening with Okay, guys, can you hear me now? Yeah. All right. So, and I think my screen is visible as well because there is a switch in the power and it went up to UPS. So I think that is not speed enough to keep the internet active. So it got disconnected and again it got connected. Sorry for that. So what I was saying is, so we created the job and we are doing a vertical flattening. And I just restarted the job. I mean, I just executed the job and the job got successfully completed. Now let us go and look at the output here. So this is how the vertical flattening is working. So here you have the ancestor as B, the descendant as D, and the depth between these two is 1, and the root flag is 0, and the leaf flag is 1. Because here in this D and B, we don't have anything related to A, so that is the reason why the root flag is 0. And we have something related to the leaf flag, which is the last node of the tree, and that is available, so it is 1. And if you look at this description, it says that the senior lead, who is B, and D is the developer, and the developer D reports to senior lead B. So this is how the data owners will read it. So this is a vertical flattening. So now let us make a horizontal flattening on top of this. And horizontal flattening, you have to mention the depth between the parent node and the child node looking at the data. So I'm giving the depth as 2. And again click on validate, and now you can see the structure of the output schema is changed. Okay, so if I select vertical flattening and validate, the structure is changing to ancestor, descendants, depth, root flag, leaf flag and all. But if I select horizontal flattening and validate, so it is now changed to current leaf level 0, level 1 and level 2. So automatically it does. There is nothing that we need to do. We just need to choose between the vertical and the horizontal flattening. And I'm executing this job once again with a new flattening type. And now we look at the data and it gives you the data in a different structure. Now this is a horizontal flattening where we have the flattening happening at the horizontal level. So first one is A. So there is at the level 0 leaf level there is nothing, and at level 0 we have A, and level 1, level 2 nothing is present, and the description is manager, and we don't have any other descriptions at the below because we are just reading at A. And if you look at F, okay, it's on the level 1, and level 0 we have C for that, about on top of that, and level 1 we have F, and there is no level 2, means there is no below that, and a trainee and lead relationship, and the descriptions are null. So this is how we'll be reading hierarchy flattening transformation, and we'll be utilizing this transformation to flatten the structures using using the built-in functions that are available within this thing. This is very simple. All you need to do is like drag the parent and parent descriptions, child and child descriptions into the respective columns here or respective boxes, and you need to choose whether it is which type of flattening is that. Is that a horizontal flattening or vertical flattening? Okay, so we will look at. Is this clear? Can I go ahead and look at the next transformation? Is this flattening clear? Yes, no. Right, I think like what is the need to specify the depth for the horizontal flattening? Yeah, Rishabh, when you are doing horizontal flattening, so you should know how many depths that are present in your data. For example, your data has 5 depths and you don't know that, and you are just mentioning it as 2. So the system will read only the 2 levels of depth, so it will not read the remaining levels of depth that are present in the data. So looking at that data, you have to provide the depth between the data, then only it can do a proper analysis in the horizontal flattening. Because if you don't give the depth, if you don't understand the data and you are just doing it normally without any understanding, then probably it will not give you a exact result what you are expecting. So you have to understand the data before you give the depth. Because horizontal means it happens in a horizontal way, so you should uh, definitely know how many levels are there, so that many horizontal flattening should happen. Okay. To specify the depth. So even though the data is huge, the depths will not be more. Okay, the depths will be in a position that you can understand it, or if not, the data owner has to understand it and he has to tell you, because even if you take the huge volume of data, the data can be huge, but the depths cannot be huge. The depths can always be less than 5, 6, or maximum at the level of 10. And if you have more than 10 or more than 20, so that data is really a complicated data and the data has to be split into subsections, then it can be read again as a normal listing. Okay, so that has to be streamlined first. So you cannot directly jump into a data which has 20 levels of hierarchy. Imagine it's even bigger than a corporate structure. So you have 20 levels of hierarchy means it is pretty bad data, I can say. So first that has to be normalized, that has to be broken down into different segments, and the junior segments will be hierarchy will be done, and these first the entire data is broken into different blocks, and within the blocks the hierarchy is maintained. For example, take an organization where the IT department is broken into one box and the hierarchy within that IT department is broken, then the development department, then the sales department, then the manager department, or then the senior management department. So all these things are broken into different boxes and the depth is maintained within these boxes. And again, all these boxes together are integrated and the hierarchy is maintained. So they have to, then you will not have much level. So if you look at the box level hierarchy, then it will be 5 to 6 levels at the max. And if you look at within the box, within each and every box, you'll have a hierarchy which is somewhere around 2 to 3 levels. So that is how you have to split the entire data, and that you'll not be doing. The data owners should do that, and they have to give it to you. You'll not be doing that. Okay, so yeah, good. So now let us look at the different transformations like pivot and reverse pivot. So just look at the graphical representations, what pivot can do and what a reverse pivot can do. Also people call it as pivot, so I'm just used to calling it as pivot, so I don't know which one is correct. So either ways, so if you look at this pivot and reverse pivot transformation, look at the graphical representation. It says that one, which is pivot, can convert the column data into the row data, and reverse pivot converts the row data back into the column data. So it is converting the row level data into the column level information, or column level information into the row level information. So this why we need such kind of scenarios, why do we get such kind of scenarios that we have to convert the data that is in the form of a column and put it back into the row? Yeah, because there can be some scenarios where we'll be doing this. Okay, there will be some scenarios where we'll be doing this, that we have to convert the data which is in one structure and put it back into the another structure. Then we have to apply the business rules on top of that and again convert it back into the normal structure. So now we will see how to use this pivot and reverse pivot transformation within the job. So I'm creating a job, new job underscore pivot underscore R pivot. Okay, so I'm creating a job pivot underscore R pivot. So first one, let me create a data flow for pivot. So I'm adding a flat file for this. I created a flat file which is having this data. Yeah, so this one. So I have a table with serial number, name, January sal, Feb sal, and March sal. So these three row column level data, I will be converting them back to the row level data, and if required, we will apply some business rules on that and put it back to the normal structure once again. So I'll look at that in this one, the pivot and reverse pivot transformation. So let me add this file to the BODS system. So this is so just give the name as pivot and reverse pivot transformation. So the folder is the source folder, source flat file folder, and select the file. The file is this one, and the worksheet is sheet 1. Use the default rows, then import schemas. Right, so wherever you get double, convert that to varchar, because sometimes the system might throw an error. So that is the bug with this tool of the version 3.0. Sometimes it will throw and sometimes it will not. So always better. Now here, open this data flow which you have created and drag and drop this file and make it as your source. So now you have the data here. You have the serial number, name, Jan sal, Feb sal, and March sal. So there are employees whose serial number, name, and 3-month salary is present. Now I want to convert these 3 months salary, Jan sal, Feb sal, and March sal, into row level information. That is in the column level. I want to convert that into the row level using the pivot transformation. So the columns that you don't want to be pivoted, drag and drop them into the non-pivot sequence columns. Okay. So here you have the headings like pivot sequence, pivot data, and pivot header. So the columns which you don't want to do sequencing on, or you don't want to do a pivot on that, you drag and drop them into the non-pivot columns list, and the columns on which you want to do a pivot, drag and drop them into the pivot sequence. That's it. You need to choose which columns you want to convert to rows and which columns you don't want to. The columns that you don't need to be converted to rows, drag and drop them into the non-pivot column box. Because you might not need all the columns to be converted, so you just do that, and this here you convert this into this one. So just go back or just validate this one to see if there are any errors. There are no errors now. Now connect this to a table and call it as pivot, and now validate again to see if there are any errors. So now I am converting the columns Jan sal, Feb sal, and March sal into the rows. And now let us look at the data, how when the column level information is converted into rows, how it will look. So now job is successfully completed. Open this, and now you see the serial number 1 is repeated thrice, the name A is repeated thrice, the sequence 1, 2, 3 is given, Jan sal, Feb sal, and March sal is given, and the salary is present here. Again, for the employee 2, it is repeated thrice, the name is coming 3 times, the sequence is 1, 2, 3, Jan sal, Feb sal, and March sal, and here we are applying some business. So based on this, we can do a group by, or we can apply some business rules, business requirement. Whenever you get a need, like you have to convert the data that is present in the column, and you have to convert that into row, and again you have to apply some business rules on top of that, then you can do that using the pivot transformation. That's good. And let us again put it back into the normal shape using a reverse pivot transformation. So here I'll create one more data flow. So looking at the graphical representation, you should be able to say that reverse pivot transformation does convert the row level information back to the column level information, or you can say it does exactly opposite to the pivot transformation. So pivot converts the row column level information into the row level information, and reverse pivot converts the row level information back to the column level information. So now let us take the table pivot which we have just created. So generally it will be saved at the bottom, if not. Yeah, here is the table, and I select this and connect it with the reverse pivot transformation. So now here you need to just do one thing. So the non-pivot columns, you drag and drop them, because on these things you did not drag and drop this. I mean, you did not do any conversion, so you just drag as it is. So if you are doing a group by on the data, when you are doing a pivot, you have to check this box saying that input data is grouped. So since we did not do any grouping on the data, I'm not checking this box. Then you have to select the column axis as the sequence number. So sequence number is the column axis on which we will be building this one, and pivoted columns. So axis 1 fixes JSAL, then axis 2 FSAL, and axis 3 MSAL. So I'm adding these things, and pivoted columns are like the data columns here. Just give me a second. I'll just cross check this one if this is correct, the way we are doing. Is correct or not. Reverse pivot. We hardly use these transformations, so okay. So yeah, we are good. Yeah, so we are doing converting in pivot data flow. We are converting 3 columns into the rows. So sorry, we are converting 3 columns into the rows. So now we have to give the axis as 3, and you have to give the column prefix, and you have to drag the header and the data here, and default value you can specify as null. So if no value is coming from this one, this columns headers, then you can select this as null. Then again, duplicate values. If you get a duplicate value, you can abort that one, or you can put it in the first row, or you can put it in the last row, so you can identify that. So let us abort it as of now, and click on validate, and then you see a structure created on this one, which is not exactly similar to our structure. So let us create a table and call it as our pivot, connect it, and now let us execute. So we'll do changes on this query using a query transformation so that we get the exact structure out. So to see the difference, we will see what is difference that is available here. So if you look at the structure of the table, you have Jan's serial number name, that you have something like the headers coming up here. So we want to remove these headers. This one, the MarchSal, FebSal, and JanSal, and also the name of the columns are not correct. So let us use a query transformation in between. So query transformation is utilized to do all these cosmetic changes on the header level information, or the column level, or on the table structure. You can do all the cosmetic changes using the query transformation. Alright, so select the serial number, select the name. So you don't want header, you just need the data. So drag and drop the data columns here, and again double click and change the names so that they just look like parent structure, JanSal. I'm double clicking on this one. Just give me a second. Hello? 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 Okay. I think that's a call by mistake. So we are converting that back to the normal structure, and now save and execute. So once you execute this job, once the second data flow gets executed, you should be seeing that in a normal structure. Okay, the job is successfully completed. Now you see the same structure that is coming in from the source. Again, you converted back the column level, the row level information back to the column level information. This is the basic functionality of Excel. So in Excel, when we want to do the changes on the data, we used to use this pivot and reverse pivot functions from the Excel. And if you look at this one, the basic thing, before all these tools are present, everything that is done using Excel. So all the data verifications, validations, consolidations, or cleansing, everything is done using Excel. So they also took these functions from Excel so that you can utilize this in a proper way. So I think we are going pretty late, and I think Jay is to go outside today. So we have only one more transformation left, so we will just complete that transformation. It is very simple. And in the next class, we will see, when we are working with the XML data and the real-time jobs, we will see more in details about how to handle this. So the last transformation of the integration transformations is an XML, this one, XML pipeline transformation. So we'll look at this one and we'll close today. So XML pipeline transformation needs an XML file. So first we need to add an XML file. So right-click, XML schema, go for new, browse for the file. So we have something coming up. Do it on Oracle tables. What is that, Jay? What can we do on Oracle tables? I did not get your question. The pivot and reverse pivot. Yeah, we can do it on any table. So once you have the structure connected to the BODS system, so you can do it either ways. So once we see it on the BODS system, for us, it is always the metadata, right? So whatever the structure that you see here, so let it be a table or let it be a structure, everything for us, it is a metadata from the BODS point of view. So it can be anything. It can be a flat file at the back end, or it can be a database table, or it can be an Oracle table, or it can be an SAP table at the back end. So for us, it is just a metadata from the BODS side. So using that metadata, you can play around, like you can convert that into a pivot, or you can do a reverse pivot on that. It depends on your requirement. So because for a simple understanding, I am creating these flat files and I am utilizing them in this jobs, because it will make some sense. Because if I just take some orders data, or if I just take some employee data and try to do a reverse pivot or a hierarchy flattening on that, then probably the data that we'll be seeing as an output does not make sense. Okay, so I'm trying to put it in a more simple way by creating a flat file, and I'm trying to utilize that within the job. So is that clear, Jay? Right, welcome. So next one is XML transformation, XML pipeline transformation. So what is an XML file? So if you look at these table structures, so this is in a structured manner. It has number of rows and columns. And if you look at the database tables, so take any table, open this, and you have the structured way. So you have columns and their data types. Okay, and if you look at the hierarchy, the XML structures, the data that is present in the XML structure is always a nested structure. So it is not a plain structure, it will be a nested structure. I'll show you how it looks now. First, let us add an XML file to display the structure. So first I'm selecting the XML schema in the file formats, and right click, go for new, browse, then XML sources. Yeah, postcode address is one of the XSD file. XSD stands for XML standard definitions. So click on OK. Then the naming space, just leave it blank and select the root element as postcode address. You can copy the same name and give it here. and click on OK, and your postcode address is added. Now see the structure. It is not a plain structure that we see on the table level. So it is a nested structure. We have a parent child, a parent node, under that you have a node for that, and then you have a child node, and under that you have a node for that. So if you look at this data, it is like a header line item information. So you have a header, for example, postcode is a header, and there are multiple addresses. So if you look at the general postal address information, so one particular postcode, the pin code number or the postal code number that is present in your area will have more than 10 to 20 addresses in this. So this is like one header has more than 10 line items. So here in this example, we'll be looking at 2 postcodes. So now let us create a job underscore XML. Okay, so I create a data flow df underscore XML underscore pipeline transformation. So I make this as my source here, and there are 2 thumb rules that you need to remember when you are working with the XML file, which we'll be looking in detail when we are working with the real-time jobs. So thumb rule number 1 is whenever you are using an XML file in a batch job, you have to make it as a file source, and whenever you are using an XML file in a real-time job, you have to use it as a message source or a message target. So since now we are using this file as XML file in file source we are using this file in a batch job, so we have to utilize this as a file source. Okay, that is thumb rule number 1. Thumb rule number 2 is whenever you take an XML file, do not forget to mention the path from where it is taken or from where it is saved. So this is an XML file, so I'm specifying the path. So you just need to click on this one, postcode address, and then go to the path XML file and specify the path from where you are trying to download this. Now if you look at the data, you have a postcode group, double click on this, and you have the 2 postcodes, SA09, SA0190D and D150LQ. These are the 2 postcodes that we have. Double click on the first postcode and you see 3 addresses related to the first postcode. Double click on the second postcode and you see 2 addresses related to the second postcode. So this is how you will be reading an XML file into the BODS system, and you can do an analysis. And XML pipeline transformation, it works in a very simple way. So you want to convert this nested structure into a plain structure, so you can directly drag this postcode and address. So it breaks that nested structure into a normal structure, whereas using a query transformation, just to show the difference, you cannot drag the postcode or you cannot drag the address, so it will not allow you directly. So for this, what you need to do is like drag from here, make it current, unnest, then make the second node as current, unnest. Now this is converted into a flat structure. We have to do these these many things to convert that into a flat structure, but using the XML pipeline, you can directly drag and drop that into the target table structure. Okay, but the difference between this query and the XML pipeline transformation is XML reads only 1 line item per header. So if you look at the data for the first header, you have 3 addresses, but it will get only 1 address. For the second header, it has 2 addresses, but it will get only the first address. That is XML pipeline. But if you look at the query transformation, it gets all the line items for the headers. So the job is successfully completed. Now look at this one. It gets only the first address, first address for the postcode, or you can say first line item for the header. But if you look at the query transformation, it gets the 3 addresses for the first header and 2 addresses for the second header. So this is just try to understand that if in case if you have XML data and you want to split it and you are sure there is only one header and line item, then you can utilize the XML pipeline transformation. We will look more in details about these XML files when we are doing these classes. So we'll look at this one in the real-time job. So that is the last technical class which we'll be looking in coming classes. So we have 2 more classes to complete the entire technical thing. One is data insight and data store configurations, management console, and reconciliations. These are simple concepts. And once this concept is done, we'll be looking at the real-time job. So probably 2 plus 2, 4 days, we should be completing all the technical things. And after that, we'll be looking at 2 different projects in one day. So how to utilize these and all these things. So then I think we can conclude the course. So another 5 days, so we can complete the training. Right, so that's it. Sorry for extending it, Jay, a little longer because I just wanted to complete this. And yeah, if you have any questions, please shoot your emails to me at bo.dataservices@gmail.com. And about tomorrow's class, I'll keep you posted. I'll try to send you an email, or I'll try to try Prakash to get in touch with you and keep you posted on tomorrow's schedule. At maximum, we'll not have a class tomorrow morning, 7 a.m. IST, and tomorrow's class will not have, and again day after tomorrow we'll have the class at the same time. So I'll keep you posted on the schedules because I mean, even I'm not sure about these schedules because of the situations that are present at home right now. So have a wonderful Sunday or Saturday night. Enjoy your life there. So we'll catch up tomorrow. I mean, day after tomorrow. I'll keep you posted on the schedules. Bye for now. Thanks for your time.